measures of variation. And I'm going to give you an example why we need to learn about the measure of variation. I'm going to give you a scenario, guys, and see if that will make sense to you, that it's good to learn about, just new measures of variation. It's an example that I use a lot in my class, and I like it because it does serve the purpose of explaining this section. Let's say, guys, you go to your bank once a week to do a transaction, and you have two branches of the bank that are at a convenient location from your home, and both of them are at the same distance from your home. The question is, which branch you should go to do your transaction. You cannot tell me it doesn't matter. Well, yes, it does matter. There are factors in determining why should I prefer a branch. Let's assume they're both offer the exact same services. The exact same services. What would be a factor for you guys to decide which branch you should go to?
Wait time?
Exactly. Very good. The wait time would be a factor. So two branches, wait time. Okay, I'm gonna listen to you since you said wait time. Okay, so we have branch 1 and branch 2. Remember, they're both 5 miles away from your home. So students could have argued and said, well, one is 5 miles and one is 10 miles, then I'll go to the 5 miles. I save on gas too. So, but they're both at the exact same distance. We're gonna make it a little bit difficult on you to decide. So you said wait time. I agree. So then this is a project for us in the class. We send 2 students to 2 branches of the bank, and we tell the students, please monitor the wait time for the first 15 customers there. So the students will go there, one student will go stand there and record the wait time, how much each customer is waiting for the first 15 customers. They come back to class, they share the data with us. So then I'll ask you, why don't we calculate, the mean wait time? We calculate the mean for each branch from each student. And we calculated the mean wait time for the first branch, it was 8 minutes. And then the mean wait time for the second branch from the second student, it was also 8 minutes, guys. So can we make a decision? We cannot make a decision based on that. It's both have a mean wait time of 8 minutes. Then another students will suggest or say, well, Mr. Bazzi, we learn another average, which is what? What's the next one you want to do, guys? We didn't learn only about the mean. We could find another one and see which one is smaller. We'll find the median. You have the data, guys, in the class. I asked you to compute the median. And unfortunately, both the median from branch 1 made the wait time was 8 minutes. And for the second branch was 8 minutes. I still cannot make a decision which branch I want to go to because they both have a mean wait time for 8 minutes and a median wait time for 8 minutes. Then a student says, well, we learned about the mode. Why don't we compute the mode and see if they are different? If they are different, we're done. We go with the one that has a lower mode. Well, we check the modes, guys. And unfortunately, the mode of the first data set was 8 minutes and the mode of the second data set was 8 minutes. So that means, guys, section 2.3 that you learned wasn't any good for you to make a decision about which branch based on wait time to go to. They all have exact same values. So how am I going to make a decision? That's why section 2.4 kicks in and it's going to support us and help us make a decision which branch we're going to go to. The first measure of variation I'm going to introduce to you guys, it's called the range. And the range, by definition, is the difference between largest and smallest value. So let's say from the students who went to branch 1, guys, we have this data. Branch 1. We had the lowest value, lowest wait time was 3 minutes, and longest wait time was 13 minutes. And for branch 2, we have the lowest value to be 6 minutes and the largest to be 11 minutes. What would be the range of wait time from branch 1, guys? What would be the range here?
Is it 10?
Yeah. 13 minus 3, which is 10. Range from branch 2, which is 11 minus 6. Remember, guys, you surveyed 15 customers each, but we looked at the customer who waited the least from branch 1 and the customer who waited the most. We got 3 and 13. We subtract them, we got 10. We looked at the customer who waited the least in branch 2. It was 6 minutes. The most is 11 minutes. 11 minus 6 is 5 minutes. Do you think, can you make a decision now, guys, which branch you should go to? You can say yes. I'm going to go with the branch that has the lowest range, which is 5 minutes. That would be okay, just to do that. But there is a drawback of using the range, just to make this kind of determination. I don't know, guys, if you can think what's the disadvantage of using the range just from the definition of the range. Look, the range is the difference between the largest and the smallest value. It's already a disadvantage to use the range, but if we don't have any other tools to use, guys, we just use the range. And it gave me for branch B to be 5 minutes, which is smaller than 10. I'll go with branch 2. So I'll go to branch 2 and do my transaction there. But it's not always good to use the range for a very simple reason. And the reason is hidden in the definition. The range is the maximum value minus the minimum value. What kind of disadvantage do you think the range will bring in? Let's see if someone can detect it. Remember, we surveyed 15 customers in each branch, and the range is the difference between the largest and the smallest. How many customers did we use when we determined the range?
15.
No, not 15.
Oh, 2.
Just 2. The one that has the largest wait time and the one that has the lowest wait time. And we ignore the other 13. We did not, just consider the other 13. This is the main disadvantage, guys, of using the range because it only accounts for 2 values and ignores the rest of the values. If you guys have a data set that has 1,000,000 values, when you use the range, you're only using 2 values and you are ignoring 999,998 values because you only need the lowest and the largest. This is the disadvantage of the range. But can it be used, as a tool, just to make decision? Yeah, it can be, but there are some better tools. And my next step, guys, is to show you, just the very next tools, which is the most important one in this chapter, which is called the standard deviation. So I'm going to explain the standard deviation, which is the second measure of variation. So the first measure of variation, guys, that you learned, it's called the range. The range of a data set is equal to the largest measurement minus the smallest measurement. And he wants us to do an example, calculate the range for class 1 scores. There's the class 1. And can you guys tell me what the range is? I have the lowest value to be 50 and the largest value to be 100. So it will be, I think you guys agree with me, it's 100 minus 50 Although the range is very easy to compute, it's sensitive to outlier. So imagine, guys, if this was an outlier, what it's going to do to the range? It's going to inflate the range big time. So that's why the range is it's a good tool, but it's not the recommended tool. The recommended tool is what I'm going to explain right now, which is called the standard deviation. So I just want you to listen to me explaining, just the standard deviation. The good news is, guys, I'm going to do the standard deviation by hand, but I will not require that you do it by hand. But you really need to have a feel where the standard deviation came from. So then when you do it, you're not just using technology, you have a good grasp and understanding of it. So I'm going to do an example and show you and tell you what the standard deviation is, explain it, give you the meaning of it, and then show you how to find it. Okay, so I use those white cards. There's a data set. I'm going to put 5 values for simplicity. Okay. Here's the data set that has 5 values. Please pay attention to it to explain, what the standard deviation. Okay. First of all, can you guys help me find the mean? What would be the mean of this data set? You can take a few seconds to find it. You just add up the quantities and divide by 5. So if you want to do it on the side, you can do that. So the mean will be 6 plus 8 plus 3 plus 2 plus 6 divided by 5, guys. 14, 17, 19, 25 over 5 is 5. Yeah, I intentionally put up the number so it will turn out to be a nice mean. So it's 5. Okay, I'm going to write the mean here under each one. Let me tell you what the standard deviation is. The standard deviation is a value that measures how much does each value deviate from the mean, how far apart the values are from the mean. For
Professor,
example,
I have a question.
any questions?
Yeah, I have a question.
Okay, go ahead.
Okay, from where will we get the 5?
Oh, the 5, this is where I got it. It just added up the 5 values to find the mean. 6 plus 8, 14, plus 3, 17, plus 2, 19, plus 6 is what? 25, and divide by the number of values 5 to find the mean, which is 5.
So every time we divide it by 5?
How many values do I have here? 1, 2, 3, 4, 5. If I had 6 values, you divide by 6. If I have 7 values, you divide by 7, and so on and so forth.
Oh, okay.
Okay?
All right.
However, you won't need to do the work, just by hand, but later we're just going to show you how to use the formula on the calculator. So the standard deviation, guys, is a value that will tell you on average how much the values deviate from the mean. Deviate, the word deviate means how far apart are they from the mean. For example, how far is 6 from the mean, guys? How far away?
1?
1, yeah, the difference is 1. So deviation from the mean. Let me write it down here. The 6 is 1 point above the mean, plus 1. How far is 8 from the mean, which is 5?
3.
3, good. And you guys agree it's a 3 above. What about the 3? How far is 3 away from the mean, apart from the mean? 2. But you guys agree it's below the mean, so we're not going to use the plus 2. We're going to use what?
-2.
Very good. How far is 2 away from the mean?
-3.
That is correct. And how far is 6 apart from the mean? +1. Okay. Very good. The standard deviation, guys, is the average of those deviations. So maybe when I say the average of those deviation, one of you is going to tell me, Mr. Bazzi, let's do the average and we get the standard deviation. I want you guys to try to do the average of this and see if you can get, just the standard deviation. How do you do the average of those deviation? You add them up and divide by 5. Let's see. What's 1 plus 3? 4. Minus 2? 2. Minus 3?
-1.
Plus 1?
0.
0 divided by 5 is what?
0.
That means the deviation from the mean is 0, but you agree with me that there is a deviation from the mean. So actually it's not 0. That means if we do it this way, it's not gonna work. So I'm gonna continue and show you guys how to find what we call the standard deviation. The standard deviation, again, it's an average value that will tell us on average how far apart the values are from the mean. You know it's not 0 because there is deviation from the mean. So let me show you how to compute, the standard deviation. Because we had a positive and negative, guys, we ended up getting a 0 when we add them up. So this is what statistician decided to do. I like it to square each deviation. If you square 1, what do you guys get? 1. If you square 3, what do you get? 9. If you square -2, what do you get? So can someone tell me, please?
4.
4. See, no more negative. If you square -3, what do you get?
9.
Good. And if you square 1, what do you get? 1. Okay. Next step. Add the deviation. Add the square deviation. I'm trying to find the standard deviation, and then later we'll use the calculator to find it, guys. So add the square deviation. If I add them, what do I get, guys? 1 plus 9 plus 4 plus 9 plus 1, which is what? 10, 14, and 9, 23 plus 1, 24. Okay, 2 more steps and we will have our standard deviation. Divide by the sample size minus 1. Okay, so I got 24 here, guys.
Professor,
Yes.
so we make like that, we say 9 or no?
What is it? This is what we did here. We took each value and we square it. So the 1, we square it, it's a 1. We square the 3, it's a 9. We square the -2, is a 4. We square the -3, which is -3 times -3, which is a 9. And then we add them up. That's the next step, which is 24.
So 3 we divided times 2. We made the line.
Yes, by itself. Yes, exactly. Not times 2 times itself.
Oh, 2 times 3?
Times 3. -2 times -2. -3 times -3 times itself. And then we add them up, we got 24. Now, how many data values do we have in the sample, guys? Can you count them for me? 1,
5.
2, 5. Okay, for the standard deviation, we have to divide by the sample size minus 1. So it's going to be 5 minus 1, which is 4. So what's the 24 divided by 4, guys? 6. There is one more thing we have to do. Let's see if one of you can tell me what that one is. There was an action that we did that we were not supposed to do, guys, and then we have to undo this action. happened right here. What did we do with those values? We
Squared.
square them. We square them. So now we have to undo the action. How do you undo a square? What do you do, guys, if you do want to undo a square? What kind of mathematic action do you do? You do what we call the square what?
Square root.
Square root of 6. So your standard deviation is square root of 6, and let me show you how to do that. Where did I get the 6, guys? I got it from here. And then I take the square root of 6. And here's how you do the square root of 6, guys. Watch. However, guys, you're going to see how easy it is when we just input the data into the calculator. So square root of 6, guys. You have to look for the square root sign, which is right here. It's in blue. So I need to press the second key first. And then this is it, right here. And now I can enter 6 here. And that's the standard deviation. So the standard deviation is, if we want to round it to 1 decimal place, it's 2.4. That is what we call the standard deviation. The standard deviation, guys, is a measure of consistency. It tells us on average how much do the values deviate from the mean. If the standard deviation is large, that means the values deviate too much from the mean. If the standard deviation is small, then the values are very close to the mean. Smaller standard deviation means the values are very close to the average. Larger standard deviation tells us that the data is widely spread out all over the place. Now, with 2.5 be considered a large value? Yes. Why? Because look at our values, guys, are small. 6, 8, 3, 2, 6, and then you have a 2.5. That's considered large, just comparing to this data set. So this is what we call the standard deviation, and this is how you do it by hand. Now, using the calculator, guys, watch and see how easy it is to find the standard deviation using the calculator. You don't need to do any of this work. First of all, you have to enter the data set into the calculator and tell the calculator that I have 6, 8, 3, 2, 6, and I wanted to find the standard deviation. So you go to Stat, Edit, and I'm going to clear L1, guys, that we used earlier. And now I'm going to put my data. You're going to like this. So 68326, we want the calculator to find the standard deviation. Not only the calculator is going to find the standard deviation for us, it's going to find the mean, the median, etc. All of the things that we learned so far. So we go to Stat, watch, guys, step by step, Calc, one variable statistics. Same thing, I told you, this is the main thing in chapter 2. Okay, scroll down, I have the list in L1. Okay. You see X bar is 5, that's the mean, guys, that we did earlier, right here. You can see it. That's 5. Okay. Don't worry about the first 2, but look at this one right here. You see what it says? S, sample standard deviation. Do you notice that this is what I got? Guys, 2.44948. It's the exact number. This is the standard deviation. And if you press the down arrow, guys, you're going to see the median. What did I do? I'll do it again. It's the median 6. And this is the standard deviation S. This is the sample standard deviation 2.4494. See, I didn't do any of the work that I showed you how to do by hand. But the formula that is built in the calculator is the formula that I used to show you the work, guys. It's already built in there. All you need to enter the data set and get the standard deviation. Before we take a break, guys, Let me ask you just a few questions just to make sure that you really have a good idea what the standard deviation is. Let's say, guys, I give 10 students a quiz and they get the following scores. Nine out of 10. Everybody gets 9 out of 10. What do you think the standard deviation is going to be? I don't need to calculate the standard deviation to figure that out. I know already what it is.
I think it's 9.
The mean is 9.
Yeah.
The mean is 9. That means there is no deviation from the mean. The mean is 9. The standard deviation by definition is how far do the values deviate from the mean. Does 9 deviate from 9? It doesn't. It's the same as 9. This 9 is the same as 9. This 9 is the same as 9. So what do you think the standard deviation is, guys?
0.
0. Excellent. So guys, on the next test, and I hope that will happen. It never happened before. After you take the first test, I meet with you and I make this announcement. You guys, I'm going to give you some analysis of how well how you performed on the first test. In the first statement, I tell you the average score was 85% and the standard deviation was 0. What can you tell, guys, from what I say?
We all got the same score.
You are all got the same score when the standard deviation is 0. Excellent. That's a good conclusion. Let me now change the conclusion. Let's say I tell you guys your average, your mean score was 85 and the standard deviation was 4. What can you say? The standard deviation was only 4 points. So average is 85. I'm not going to give you your individual score. I want you to guess. Just keep you guessing here. So your average, the average of the class is 85 and the standard deviation is 4. What kind of conclusion you can make?
Some people got like an 89.
Exactly. So everybody is within the vicinity of 85. Some of you got a little bit more and some of you got a little bit less. Very good. But you can conclude that everybody is still passing. Do you guys agree with me? Because you're very close to the average. A standard deviation of 4, guys, means that it's very close to the average. So everybody is very close to the average. You could be a little bit below or a little bit more, but you're close to the average. Now let's change the statement, and then I promise you take a break after this. I tell you your average score on the test is 85, but the standard deviation was 23 points. What kind of conclusion can you make, guys? What can you tell about the performance of the class? So remember, the average is 85, but the standard deviation was 23 points. What kind of inference you can make? Not difficult, guys. You can say something.
That there was a variance of scores from
Exactly. Very good. Excellent interpretation. I just told you earlier, guys, the larger the standard deviation, the more spread, the widely spread the data is. When the standard deviation is 23, guys, it means there are some group of students who perform very poorly, and there is another group of students who perform very well. They averaged an 85, which is a good average, but there were so many high scores, there are so many low scores. Do you think I will be concerned when the standard deviation is 23 points in my class? When I'm doing out of 100 scores? Should I be concerned, guys?
Yes.
Definitely. I always compute the standard deviation, guys. And if the standard deviation is high, this is an alert to me to tell me there are some students who are performing extremely well, but there are some students who are performing extremely low. So that's where I try to do an intervention there. But if I do the average of the class, guys, it's, let's say, 79, and I end up with a standard deviation of 3.5, I wouldn't be too concerned, because it seems to me like everybody, just is reading it on the same page. This is how important the standard deviation, and it is used in lots of real life applications, guys. People find the standard deviation. If it is low, they say things are consistent. If it is high, they say things are not consistent. Maybe you need to make some changes. So take your 15-minute break, guys. What time is it now?